Right. So far, we've been only dealing with right triangles. So you have Pythagorean theorem and you have sine, cosine, tangent. All of that goes out the window if you don't have a right angle anymore. Those theorems aren't applicable to, by definition, they don't work unless you have a right triangle, right? So that's where law of sines and law of cosines comes in. So law of sines is used to find angles and sides of what are called oblique triangles. And oblique simply means that there's no right angle. So it's not a right triangle, is all that means. So as a heads up, I don't draw any of these triangles to scale. I don't even bother to try. Like, I just draw something with 3 sides and go with it because you don't have a right angle in there, and I'm not going to get out a protractor and start to try to like measure. Did you guys use those protractors in geometry? Like, remember measuring angles and you had to like draw a, I don't remember. Anyway, we're not going to do that in here. It's not going to be to scale. You're just going to draw something with 3 sides and like move on with your life, right? So in order to use the law of sines, you must have 3 pieces of information and at least 1 side. For example, if all you're given are the 3 angles, you can't figure out what any of the sides are. You need to at least know what 1 side is. So I'm not going to just give you the angles. You wouldn't be able to solve the problem. So what I'm going to do right here, I'm going to give you an overview of what the entire rest of the unit's going to be. We're not going to do all this today. This is just kind of like the outline of where we're headed, right? So here's your possibilities. You can have 1 side and 2 angles. So if you were given 1 side and 2 angles, that would be the patterns: angle, angle, side, or angle, side, angle. How are those different? Angle, angle, side versus angle, side, angle. Like for this one, where's the side that you know? Yeah, good. I'm not trying to trick you. The side is in between the other 2 angles. So you see how the S is in between the 2 A's? You following me there? And in this one, the side is not between the 2 angles. All right, you could have 2 sides and the non-included angle. Non-included means it's not in between. So if you have 2 sides and the not included angle, that is side, side angle. You can spell it the other way, it's funny. I don't mark it wrong. All right, for any of these patterns, you're going to use the law of sines. For today, we're only going to do these 2 patterns. Again, I'm just giving you an overview of what's coming up for the rest of the unit, but for today, we're just going to do these 2. All right, you could have 2 sides and the included angle, which means that angle is in between them. That would be side, angle, side. So you have 2 sides and the included angle, side, or you could have all 3 sides, which is side, side, side. For these patterns, you would use the law of cosines. So figuring out what the pattern is really, really crucial because it tells you how you're going to approach the problem and which law you're going to use. So if you can't get the pattern, you're kind of stuck for the rest of it. So you've got to be able to identify them. All right, now I'm going to show you where the law of sines comes from. You might not care, but I'm going to show you anyway, all right? Draw yourself a triangle. We're going to call it ABC. And then the lowercase letters go across from the uppercase letters. So baby A, baby B, and baby C. Now you can't use sine unless you have a right triangle. Sine, cosine, tangent are only for right triangles. So what I'm going to do is drop down the height, call that H, and now I have a right triangle. Actually, in fact, I have 2 right triangles, one on the left side of the picture and one on the right side of the picture. Now I just brought sine, cosine, tangent back into the picture. So let's do sine of A. Sine of angle A. Sine is opposite over hypotenuse. So hey guys, I'm trying to wake you up here. Looking just at this right triangle, what would be opposite over hypotenuse for A? Good, H over B. I feel like you guys think I'm trying to trick you or something. I'm not. Now I want to get H by itself, so I'm going to multiply over the B. So it would be B times sine of A is our height. We're now going to do the exact same thing on the other side of the picture. So try to just look at this triangle. And we're going to do sine of angle B. Again, sine is opposite over hypotenuse. So if B is your point of view, that would be what over what? H over A, good. And if you go to get the height by itself, you would multiply over the A. So here's where I'm headed with this. If this equals the height and this equals the height, then they equal each other. Good. So we're going to set these two things equal. So B sine of A equals A sine of B. And whenever you write out the law of sines, what happens is we just get all the A's to one side and all the B's to the other side, kind of grouping them together. Watch me point to this. If I divide over this sine of A and I divide over this sine of B, like if I just divide them to the other side, you're going to have A over sine of A equals B over sine of B. That is your law of sines. As you set up that ratio, it would also equal C over sine of C. So in order to set up that ratio, you have to have a side across from an angle. So you have to have a side across from an angle in order to set that up. Now you are going to find the angles first and then the sides in order from smallest to largest. It doesn't, disclaimer, it doesn't actually matter what order you do anything in for what we're going to do today. But when we get to some of the other patterns, it is going to matter. And so what I try to do is just have everybody be consistent and do the problems the same way from the very beginning. And then you just always do it in the same order and then you don't have an issue. Does that make sense? Like today, it's not going to matter, but later on it will. So just do it the same way. Find the angles first, then the sides, smallest to largest. And then remember, the smallest side is across from the smallest angle. The medium side is across from the medium angle and the largest side is across from the largest angle. So you can use that to kind of check your work. Because if you have a teensy little angle and you get an enormous answer for the side across from it, you can be like, oh, I probably typed something wrong or I set it up. Okay. Now, that was me going through a lot of explanation. Doing the problems actually goes pretty fast. This generally goes so well that by the time I finish the second one, everyone started the third one and is like partially done with it. Okay, so just listen, this will go just fine. Every year I do this, it's fine. Draw yourself a triangle. I don't care what it looks like. I'm not going to get out a protractor and measure it. It's not to scale. Just draw something with 3 sides. Now, again, for today, it actually doesn't matter, but later on it will matter how you order these. Always start with the bottom left, then go to the bottom right, then go to the top when you're labeling. Again, today it won't matter, but it will later, so just be consistent. So when it says A is 26 degrees, start with the bottom left. Again, I'm just trying to set you up for success later on. If you get used to doing it in this order, then you'll be fine later. Then go to the bottom right. So the next one we were given was B. So that'll be 50, and that means the angle up here has to be C. We weren't given that one, that's fine. And then we were given side C, which would be 12. That'll go right here. We are missing baby A and baby B. So here is my question. What is the angle and side pattern for this one? Look at what you have filled in. What is the pattern? Good. Angle, side, angle. Do you guys see that? And again, today, we're only going to do these 2 patterns. This is all we're doing today. This was an overview of the rest of the unit, but these are the only 2 we're doing for today. So it's going to be one of these 2. The side is either in between the angles or it's not, all right? So angle, side, angle. Now list out what you're missing. And I usually list it in the order I'm gonna find it. We're gonna do the angles first. So first we're gonna find angle C. And then you wanna find the sides smallest to biggest. So which is gonna be smaller, side A or side B? Good, why is A gonna be smaller? Yeah, that's the smaller angle, and then B. So that's the order we're gonna find everything. Got your calculator ready? We're gonna do a lot of typing, all right? What do all the angles have to add up to? Good, so do 180 minus 26 minus 50. If you take 180 and subtract those others, that will give you what's left for the third angle. Do you get 104? Now, 104 is an obtuse angle. It would actually look like this. Again, the picture is not to scale, which is fine, right? So put 104 degrees on that line, and you can put 104 in the picture as well. All right, now we're gonna find side A. In order to set up this ratio, you need a side across from an angle. So do we have a side across from an angle? Look at your picture. Which ones is it? A, B, or C? Do we have a side across from an angle? C, do you see that there? All right, it's gonna be 12 over sine of 104 equals A over sine of 26. So you set them up across from each other. 12 over sine of 104 equals A over sine of 26. Now the way that you type this in is you cross multiply and divide. Let's do this. Everyone watch me type it, and then I'll pause and give you a moment to type it, but just everybody watch and let me make sure I'm in degree mode, okay? I'm gonna cross multiply. 12 sine of 26, close parenthesis, divided by sine of 104, close parenthesis. You have to close the parenthesis because when you hit sine, it starts a parenthesis for you. But go ahead and do that. Cross multiply and divide. You'll get your answer. You need to do 3 decimal points. Everybody make sure you can get your calculator to tell you that. If you can't, you will be so stuck. If you can't get that, you can't get the next thing. Again, today it won't matter so much, but later on, you're gonna have to like store those. Remember we did store alpha A, enter, and then reuse them. Like it's a lot of fancy button pushing. So you're gonna have to get used to it. Did anyone else get 5.421? I'm getting like no feedback from you guys today. You know, it's only Wednesday. Okay. Setting up the last one. Hey, guess what? It's gonna start the exact same way. 12 over sine of 104. You're still doing the same triangle, so that didn't change. 12 over sine of 104. Now the other side's gonna change though, because now we're trying to find B. It would be B over what? Sine of 50, good. Go ahead and type that one in. You're gonna cross multiply and divide. You would type 12 sine of 50, close parenthesis, divided by sine of 104, close parenthesis. And then if anyone's brave, you can share what did you get before I hit enter on mine. And it should be a larger answer than what you got before because you're finding them smallest to largest. So it should be a bigger answer. So if you got like an answer smaller than 5, you could be like, oh, I must have mistyped something. And those are your answers. You're finding all the missing stuff. Let's try it again. Draw a triangle. I don't care what it looks like. Just draw something with 3 sides. It's not to scale. It's really not to scale because the first angle is 110. Which again, that would be obtuse. It would look something like this. I don't care. You can draw an obtuse triangle if you want. I just don't see a point in it. Start at the bottom left, then go to the bottom right. This time the bottom right is C. It doesn't matter what it's called. And when you do delta math, they might call them PQR. Like the letter doesn't matter. Just start at the bottom left, go to the bottom right. And then that means the angle at the top has to be B. And then we're given side A is 19. We don't have side B or side C. So what is the pattern? The angle and side pattern. Good. Angle, angle, side. Hey, Miss Cole, what if I write SAA? That's fine. I don't care. So let's list out what we're missing. You would find the angle first. So we're going to find angle B. And then you want to find the sides smallest to biggest. So what's the next smallest side that we're going to find? Or I guess we don't know, huh? I guess we have to find angle B first. How would we find angle B? And 25 from 180. All right, good. Everybody do that. 180 minus the other two. That'll give you what's left. What did you all get? 45. Perfect. So 45 goes there. Okay, now we can tell. Which is the smaller one, B or C? C is the next smallest. It's across from the smaller angle. So just write them in the order you're going to find them. Now, in order to set up the law of sines, you have to have a side across from an angle. Do we have a side across from an angle? And if so, which one is it? Hey, good. Do you guys see that? 19 and 100. Okay, good. 19 over sine of 110 equals, and then what do I want to put on the other side? Good. C over sine of 25. Again, I see a lot of you typing it already. That's good. Cross multiply and divide. You're going to type 19 sine of 25, close parenthesis, divided by sine of 110, close parenthesis. What y'all end up with? Good, 8.545. Now, when we do the last one, you should get a larger answer than 8, again, because we're finding them smallest to biggest. So you can use that to kind of check your work. Your ratio is going to start out the same way. You're still doing the same problem. 19 over sine of 110, that didn't change. What's going to go on the other side this time, though? What over that? Good, B over sine of 45. And you might have said that, I just didn't hear you, I'm sorry. Go ahead and cross multiply and divide. We'll get our answer for the last one. Again, you should get an answer bigger than 8 because we're finding them smallest to biggest. I got 14.297. Is that good? Okay. Yes, ma'am. So you kind of missed me saying this, but that's fine. I can say it again. It bears repeating. For the patterns we're doing today, it actually doesn't matter. But patterns that we're going to do later in the unit, it does matter. So that's why I try to just coach everybody to do it that way from the very beginning. And then you're just used to it and then you're good later on. All right, number 3, go ahead and draw a triangle. Start at the bottom left. That's another thing that for today, it kind of doesn't matter, but later on it will. Start at the bottom left, go to the bottom right, then to the top. So bottom left is going to be A, 50 degrees. Bottom right will be B, 72 degrees. That means C goes at the top. And we have side C, which is 12. We're missing side A and side B, baby A and baby B. So what is the angle side pattern for this one? Good, angle side angle. The side is in between the two angles. So let's list out what we're missing. What are we going to find first? Put it in the order you're going to find it. C, good, angle C. And then which is the smaller of the two sides we're missing? A is the smaller one, good. So A and then B. So subtract the other two angles from 180. I got that C is 58. And then in order to set up the ratio, you have to have a side across from an angle. Which is the side across from an angle that we've got? C, good. I'm successfully waking you up. If I just send you into next block awake, it'll be good, right? 12 over sine of 58 equals what over what? Good. A over sine of 50, you're going to cross multiply and divide. Who's feeling brave? What did you get? Perfect. And when you do the last one, you should get an answer larger than 10 because you're finding them smallest to biggest. So if it's not bigger than 10, then you know you had a whoopsie somewhere. All right, how does the last one start? Yeah, 12 over sine 58, the exact same thing because it's still the same triangle. This time it's going to say b over sine of 72. So go ahead and cross multiply and divide there. I got 13.457. Okay, thank you for confirmation because if I hit a button wrong, it's going to be wrong. Do you guys feel like you could try number 4 on your own? If you guys try number 4 on your own and talk to each other, talk to your group, and it goes well, then I won't make you do question 5. Do you guys get what I was saying about how after you do a couple of these, kind of just doing the same thing over and over again, just with different numbers in? I'm going to pause the recording. Everybody try number 4, and then I'll go over it for you. All right, let's see how this went. What did you put for the angle and side pattern? Good, the side is not in between the two angles. So angle, angle, side. All right, we are gonna find angle A first. And actually, let me go ahead and find that before I decide the order of the other two. What did you guys get for angle A while I'm typing it? 55? All right, so which side do we find next? Again, you want to do it smallest to biggest. All right, B would be next. That's across from the 37. And then A would be last. All right, so we need a side across from an angle. That would be these two. So you would have 22 over sine of 88 equals B over sine of 37. So you're going to cross multiply 22 times sine of 37 divided by sine of 88. What did you get? Anyone want to share? All right, good, me too. And then the last one's going to start out the same way, except what is it going to say over here? Good, these two, A over sine of 55. And then cross multiply and divide. It should be an answer bigger than 13. I got 18.032. Okay, heads nodding. Have you guys got it? Okay, I will still fill in number 5 when I go to take a picture of this and post it if you want to try it for extra practice, but you're going to do a bunch of practice for homework on Delta Math anyway. All right, the last thing that we're going to look at are triangle area formulas to find the areas. I'm going to explain to you where this first one comes from, whether you like it or not, you'll be fine. Okay, go ahead and draw our triangle ABC, exactly like you did on the other side of the paper, but you're going to be fine. Just draw it again. It's 3 sides and 3 angles. Give me a break. And then we're going to drop down the height. I'm going to tell you if nobody knows, but does anyone know the area formula for a triangle? Either from geometry or just being alive. Like, does anyone know how you get the area of a triangle? No. Oh, there's a 1/2 in it. Yay! 1/2 base times height. So 1/2, what's the base of our triangle? C, and then times H for the height. We're gonna do a similar thing to what we did on the other side. Try to look just at this triangle. We're going to do sine of angle A. I can do that because this is a right angle. So it's a right triangle, all right? So sine of A equals what over what? Opposite over hypotenuse. So it'll be H over B. I want to get H by itself. So I'm going to multiply over the B. and you can substitute that in for the height. So you would get area equals, and the reason I'm writing out the whole word area is because the capital A stands for angle A, so you don't want to confuse those. That's why I'm writing out the whole word area. So area equals 1/2 C times B sine of A. Now there's two other versions of this, and I don't want you to view them as three totally separate pieces of information. All I'm gonna do is shuffle the letters around because it really doesn't matter what stuff's called. Again, you could call it X, Y, Z and it doesn't matter. You could shift the triangle and it doesn't make a difference. So you've got 1/2 CB sine of A. You could also have 1/2 AB sine of C. I just shuffled the alphabet. And then you could also have 1/2, what's the one I didn't do yet? BC, oh no, I already did BC, hold on. What's the one I didn't do? AC, sine of B. Those all mean the same thing. Do you see what I did there? How I've got like these two sides and then the angle's the third one? Like AB and then sine of C, AC, sine of B. Like, don't view those as three separate things. They all mean the same thing. All right, leave a little space here because there's one other formula, but I want to do the examples with these first. Let's just go ahead and practice them. We're going to do 6 and 7. So look at what I gave you. Which one of these, let's call them the first one, the second one, and the third one. Which one of these matches with the information that's given to us? The first, the second, or the third? The first one, do you guys see that there? 1/2 BC sine of A, that's what I gave you. So area is going to equal 1/2 times 10 times 12 times sine of 22 degrees. All you have to do is put that in the calculator and you have your answer. So just everybody type that. 1/2 times 10 times 12 times sine of 22. You get 22.476. Now, typically these problems, you aren't given units, but let's pretend you were. Let's say that like this side was 10 feet and this side was 12 feet. When you find an area, it would be feet squared. Good, because it's 2-dimensional. Do you guys understand a volume? Like if you were filling something up would be cubed? Okay, has to do with the dimensions you have. Now look at this one. You may notice we don't have enough information to do these. That means we're going to have to solve part of the triangle. So draw yourself a triangle because you need at least 2 sides and we don't have 2 sides. So we're going to have to find that. Angle A is 55, start at the bottom left. B is 68. C will go at the top. We don't have that one. Side C is 9. So first we're going to find angle C. Everybody subtract from 180, find me angle C. What is angle C going to be? Go ahead and type it in. We're finding this missing one here. What is that going to be? G7? Now you can set up the law of sines because you have a side across from an angle. So it'll be 9 over sine of 57 equals, and then what's the smaller one, A or B? Want to find the smaller one? A, good. It'll be A over sine of 55. I'm sorry, because I know A kind of looks like 9. This one's a 9 and that one's an A. Hi. Please go ahead and type this. I see a lot of you already. Go ahead and cross multiply and divide. You're going to type 9 sine of 55 divided by sine of 57. And that will give you A. Did you get 8.790? Quick, capture it. Do you remember how to store it? We're going to need to reuse that number. How do you store? Yeah, and we're going to use A since it's A. Store alpha A, enter. Store alpha A, enter. Where's the store button? Like right above on. Store alpha A, enter. Store alpha A, enter. All right, and then let's see which version of this formula we can use. We have A and we have C, side A and side C. So we're going to use this one, the third one there. Do you see that? So our area will equal 1/2 times A times 9 times sine of angle B, which is 68 degrees. So when you type that, you're going to type 1/2 and then alpha A, and it will copy and paste that number in for you, times 9 times sine of 68. Did anyone else get this? 36.677. Okay. The last formula we're going to look at. This one is called Heron's formula. Everything in math either is like named after the person that came up with it, or like just is exactly what it says that it is. But this one's called Heron's formula. This one I think is cool. I don't have a proof for this one. Like I'm sure it exists, but it's cool that it works because I actually don't know how it works. What you're going to find is this S value. It is 1/2 A plus B plus C. So this guy figured out that if you add all the sides together of any triangle, divide it in half, the area comes out to be, and you're gonna have to draw a great big square root, that S value times S minus A, S minus B, and S minus C. Again, I don't know what the proof of that is. It probably takes pages to prove it, but that's cool. I know you're all really tired, but if you take the sides of any triangle, add them up, divide it in half, and then do a square root of all that, it gives you the area every time. That works. That's neat. I'm sorry. That's cool. It is. Let's try that. So do you see how for number 8, I gave you all the sides? First thing you're going to find is that S value. Add them together, divide it in half, tell me what you get. Add all those together, 12 plus 16 plus 25. Divide it in half. What is our S value? Yeah, good, 26.5. Add them all up, divide it in half. Then your area equals, draw a gigantic square root. It's going to be that number, 26.5. And then I usually just draw like 3 more blanks. It's going to be 26.5 minus 12. Should be 14.5, bless you. And then 26.5 minus 16, which would be 10.5. And then 26.5 minus 25, which would be 1.5. You just take that number and subtract each of these. Go ahead and type that in. Square root of all of that will give you the area of the triangle, like every time. That's cool. Cool, guys. You know it is. Just won't admit it. So what would be the area for this guy? Oh, I got a bigger number than that. Yeah, I got 77 and some change. Did anyone else get 77? You probably just forgot the 1.5. 77.794. Again, I didn't put units in this, but like say the units were inches, then this would be inches squared since it's an area.